Welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. In this lecture, we are going to study various ferrous metals and alloys. So in the previous lecture, we have seen what are the different engineering materials being used in the industry and how they can be utilized in very good manner so that we can get best out of them. So in order to do this, we have broadly divided the engineering materials into two categories. One, metals, and second one, non-metals. Now, we are in the first category where we are going to study different metals. So, the different types of metals includes another two types of classification, that is ferrous and non-ferrous metals. So ferrous metals and non-ferrous metals are the two categories which we have to study separately because the metals which have ferrous in them has some important properties and they have wide range of applications, as well as the metals which does not have iron in them. They have a separate range of applications and they are used in sometimes in the place of ferrous elements. Now, in this lecture, we are going to study what are the different ferrous metals and how these ferrous metals combined with other metals to form alloys. Now, let us try to see the basic definition of ferrous metal. So, the ferrous metals are iron-based metals which include all varieties of irons and steels. So, any metal, if it contain a very small proportion also of iron, it can be called as a ferrous metal. So the term iron, cast iron and steel in reference to the metal in which the element iron is major element. So we have to see that ferrous is the elemental formula, elemental name of iron. If any metal has more percentage of this ferrous, it can be called as a ferrous metal. Otherwise, it can be called as non-ferrous metal. Okay. So it does not differ to any specific metal or alloy. The name itself indicating that the metal contains some amount of iron. But they are loosely used to indicate a general type of iron alloy. Even ferrous metals, there are different types are there. Now we are going to see about the different types of ferrous metals available in the market and their applications. And also we'll see what is the different composition of these metals. So in the pictures we can see there are two types of metal rods. So these are mild steel rods. So they are made up of mild steel, which is a composition of iron, where it shows a ductile property. Okay. Now there are two types of forms are there. Depending on the usage and application, they are prepared in a particular way. Now here we have a rectangular cross section or square cross sectional bar. So they are called billets. And other type is sheets. So these sheets are made up of mild steel where they can be used for laying. Different applications will be there. Now these are made up of iron. So the key component or the major component of metal present in this metals is iron. So they can be called as ferrous metals. Now let us see what is the flow sheet for the production of iron and steel. Now see here, initially we have to take the raw iron ore from Earth's crust. It is digged out. It has to be processed and refined using different techniques for getting the final form of irons, which we are going to use in our engineering applications. Now, to do this, we have to undergo the iron ore, which is taken, extracted out of the Earth's crust, has to undergo different processes where it will be converted into different forms of iron. So, depending on the type of process and type of refining method, so we will get different types of iron. Like each iron will have a particular property where they can be used for a wide range of applications. Now see here, when the iron ore, raw material of the iron is taken. This iron ore is taken and it is refined or heated in the blast furnace. So when it is heated in the blast furnace, we will get a raw iron that is called pig iron. So this pig iron is the one which does not have any impurities like solid impurities which we can be seen with naked eye. Like when the iron ore is extracted from earth, it contains large amount of stones, sand, etc. So all these particles has to be separated. So we have to take this iron ore into the blast furnace where it is heated hot enough so that all the impurities will be removed like sand, rocks, etc. So these are to be filtered from the iron ore, and then the iron that is obtained from this process is called pig iron. Now pig iron does not have very good properties. It is like a very raw form of iron. It is very raw that it can be modified or it can be converted into some other forms where it can be used in multiple applications. Now see here, if this pig iron is taken into foundry, where in foundry we have to reheat this pig iron and it can be cutted and it can be molded into required shape. Okay, we are not going to cast. So casting is a different technique which is used to get the required metal shape by converting the solid metal into liquid form and pouring it into required mold cavity. So that is all casting. We are not doing casting here. We are going to take this pig iron into foundry where we will reheat this. After reheating up to the recrystallization temperature, and at this recrystallization temperature we will apply some pressure on the iron billet or some iron bar where it can be converted into a new shape. Okay, so from cupola furnace we will get cast iron. So cast iron is the thing which does not have any ductile properties. Okay, cast iron is the metal. It is a form of iron where it only has very brittle property, which means it can bear large amount of compressive load, but it cannot take any small amount of tensile load. Okay, suppose if this is a metal bar, if I apply load in this direction like tensile loads can break this bar very easily because it is very brittle. It does not have that tensile load bearing capacity, but it can carry large amount of compressive loads. When the load is applied in the opposite direction, this is called compressive load. So compressive loads can be taken by this brittle material, that is cast iron. Okay, so it has some properties and it has some advantages and it has some applications also. Even though it does not have ductility property, it is not said that the cast iron cannot be used in the industry or in the engineering field. It has some applications where cast iron is required particularly. So one of the example for cast iron where it is used in the engineering field is when we take the example of a lathe. So the lathe machine bed is made up of cast iron. Okay, so lathe machine, we have a common platform bed on which the entire machine, the tool post, the tail post, tailstock, headstock, etc. These are all fixed on a platform that is called the bench. So this bench is made up of cast iron. So this bench will be very thick and it will be very heavy. Why? Because it is made up of cast iron. It is made so strong that it can bear many dynamic loads and it can carry heavy weights because the machine itself has to stand on this bench. Okay. Now that is one example where cast iron is used in the applications of lathe. So lathe bed is made up of this cast iron. And after processing, we will get malleable iron. See here, this is malleable iron where we will get a different form of iron and it exhibits completely different property. We have seen in the previous lectures there are multiple properties of iron. multiple properties of metals. So engineering materials will have different properties, and one of them is malleability. So the property malleability is nothing but it is the ability of a metal to be converted into thin wires. So it can be drawn into thin wires or very thin sheets. Okay, so this property is called malleability, and after processing the cast iron, we can get a very good property for the iron. The property is called malleability, where iron can be converted into thin wires and sheets. Okay, and this is one process. So we have taken the pig iron and we have kept in furnace, and from there we have taken it to cupola furnace, and after processing we got cast iron, and even further processing we will get malleable iron. And if the pig iron is taken, if it is melted or solid form is taken into different processes, like we have three processes here. So Bessemer converter, open hearth process, electric furnace. So all these processes will give you steels which are used in general purpose. Okay, we will get steel in all these processes, and particularly in electric furnace there are another two types of processes are there. One is arc furnace and a high frequency furnace, where we will get in arc furnace we will get steel which is used in normal applications, and in high frequency furnace it is a special device which is made for preparation of tool steels. That means the iron which is processed in this high frequency furnace can be used as a tool for cutting other metals. Okay, we are using iron. We are taking pig iron as a raw material here. If we want to cut the pig iron with iron, we have to make some process, or we have to modify its composition using a high frequency furnace, where the end material that is coming out of this high frequency furnace is so strong that it can be used to cut itself, like the tool which is made up of steel. This steel tool can be used to cut iron itself. So this is a very good process where we will get very strong tools which are generated from iron. And here another process is there, where the solid pig iron is taken, and this pig iron is processed in puddling process. There is a process called puddling. After this puddling process we will get wrought iron. So this wrought iron is another form of iron where it has another wide range of applications. We are going to see that in the coming slides. And after processing we will do cementation process. We are going to apply cementation process to this wrought iron, where we will get blister steel. Blister steel is another form of steel, so it has some applications, where after melting it we will get crucible steel, and if we forge this we will get shear steel. So depending on the type of process the steel is undergoing, we will get different types of steels. Okay, so where do we get this? It is obtained from blister steel. So the blister steel itself is obtained from wrought iron. So this is wrought iron, where it is used to prepare many different types of steels. So each steel has a particular application. Okay, so these are the different so this is the flow sheet of the production of iron and steel from iron ore. Okay, from raw material we are producing some very hard metals and very important metals of iron. That means different forms of steels. So these steels will have multiple applications in wide range of engineering fields. Now when we see iron ores, so different iron ores are there. Mainly there are four types of iron ores are there. First one is magnetite, second one is hematite, third one is limonite, and fourth one is siderite. So these are the four types of iron ores which are available in the earth's crust. Mostly these four are abundantly available because they are more in the earth crust. So they are considered, and their chemical formula is also studied here. So where these type of iron ores are available in particular countries only. Okay, not every iron ore is available in India. So some are available in India, some are available in other countries. So depending on the application, they are modified, they are processed, and final products are prepared. Now the first one is magnetite. It contains 72.5% of iron. So it is the highest iron content present in any iron ore. So its chemical formula is Fe3O4, where it is mostly available in India, Salem district near Chennai, and Sweden, some parts of Sweden, USA and USSR. So in these countries also, they can find magnetite. So magnetite is very useful in most other applications because it contains more iron content. And second one is hematite. It contains about 65 to 70% of iron, where its chemical formula is Fe2O3, slightly different. That is why it is given a different name. So in India, it is mostly found in Bihar, Odisha, Andhra Pradesh, Madhya Pradesh, Mysore, etc., and also in USA. So hematite is found in most of the places in India, and some parts of it in USA. And limonite contains about 60% of iron, and its chemical formula is 2Fe2O and 3H2O. So this is the chemical formula for this limonite, where it is mostly found in France, UK, Spain, and very little amounts of this will be found in India. Okay, and then we have fourth kind of iron ore. This is siderite, which contains 40 to 44% of iron, and its chemical formula is FeCO3. Okay, so this is mostly found in France. So large amount of this iron ore is found in France, followed by UK, Spain, India, and other countries. Okay, UK, Russia, India, Raniganj. In West Bengal of India, this siderite is found. So it can be used to refine. So it can be used to prepare different types of steels. So next thing is, we are going to see what is steel and how this steel is prepared, what is the basic definition of steel, and how this steel is classified. Now, steel, it is called as master steel in engineering application. In general call, we will say steel. Okay, it is obtainable in great quantities, both in wrought and cast forms. Its plasticity, whether at room temperature or elevated temperatures, allow it to be worked either hot or cold. Okay, so the steel can be, it is found in large quantities, both in two forms, that is wrought steel and cast steel. So each type of steel has their own properties, and because of the high plasticity, that is the property of this steel at room temperature, so they can be used for either hot working or cold working conditions. We know what is hot working and cold working. When a metal is worked by heating it to the recrystallization temperature, then the process is said to be hot working. If it is not heated, or if the temperature of the object of the metal is not near the recrystallization temperature, then the working process is called cold working process. By varying the carbon content and by suitable heat treatments, we can alter the properties from a very soft workable steel of the type in pressed metal parts, wire and similar materials, okay, to hard, strong, suitable for use in tools, machinery, where great strength and hardness are required. So depending on the application, this steel can be modified. It can be prepared like a soft workable steel or a very strong steel which is suitable for preparation of the tools used in machinery, machine cutting. Okay, so depending on the type of application, the steel can be modified accordingly and it can be used. And the second type of iron is wrought iron. So wrought iron is the oldest form of iron made by man. So we know our ancestors have found this iron ore in Earth's crust and found it very useful for the preparation of tools like knives and swords, because these knives, swords, and spears can be used for hunting. So that is why these metals are digged out of the earth. They don't know how to purify them because they are primitive, because they don't have the knowledge of science. Yet they have prepared tools out of iron. Where do they found this iron? This iron is found mostly in the earth's crust. They have digged up. They have digged the iron ore and they have filtered it how to some extent, and they have prepared tools using this wrought iron. So wrought iron is an old technique where it is used for preparation of tools like swords and spears, which can be used for hunting animals. So this is an old technique made by the man. This is the first form of iron that is made by man, and it was originally produced by slow reduction of the metal from the ore in forge fire. So back then they don't have the technology of melting the steel into liquid form, which because of which it can be purified easily. Okay, so they have only one technique, that means that is forging. So they have to take the billet of metal and they have to forge it, like they have to heat it so long that it can be converted into required shape. So this reduction process resulted in a very impure iron, which requires further refining by mechanical working. So due to not heating up to the liquidation form, this iron ore will have large amount of impurities, like other foreign particles will be present in it, and this may cause damage or failure while working. Okay, if the iron ore does contain any impurities like rocks or solid, sand particles, etc. So what happens when these metals are used for working purposes like cutting a tree or hunting an animal, they might break because they have impurities, and the inner crystalline structure is not so uniform. They may break easily. So this is because this is an old technique. They don't know how to purify this iron. So this is an old technique used by man. Okay, so this entire thing is done by forging the iron and hammering it with hand. So it is a very low in carbon, and iron silicate or slag is distributed throughout the base metal, in which gives it woody or fibrous appearance when fractured. So as we have said earlier, it contains large amount of impurities. That is why when this metal tool is broken, we can see the inside structure like it is like fibrous structure, because it contains large amount of slag or iron silicate, etc. Okay, so this is all about wrought iron, and then we have cast iron. So cast iron is a iron form where this can be used to, like it has many applications. There are different types of cast irons also. Now we are going to see them in detail. So there is pig iron is unsuitable for casting as it contains impurities, so in high percentage. So we have to purify this pig iron to form cast iron. So cast iron is the purified form of pig iron. So we know pig iron is the blunt form or raw form that is obtained from iron ore. So to render it suitable for desired purposes, it is refined in the furnace known as cupola furnace. So this cupola furnace and its working is also very important, as in the perspective of engineering. We have to study how this cupola furnace works. Okay, the refined products is termed as cast iron. So after the processing in cast cupola furnace, the final product obtained is cast iron. And then we have a classification of cast iron. There are different types of it: grey cast iron, white, mottled, nodular, malleable, alloy cast iron. Now we are going to see each cast iron in detail. So it is basically, it contains 2.5 to 3.8% of carbon. Now all these cast iron types are based on the percentage of carbon. So by varying the percentage of carbon in them, we can identify each different types of carbon, and we have to name them based on the percentage of carbon. Okay, so here the carbon percentage is about 2.5 to 3.8%, and silica, aluminum, silicon, manganese, potassium, sodium, etc. are there. So these are all the other metals which are present in the iron ore, yet it has major percentage of 2.5 to 3.8 percentage of carbon along with iron. So this is called as grey cast iron. So it has many properties, like it is readily casted into desired shape. It possesses low melting point of the ferrous alloys, and it has high resistance to wear. Okay, it has high resistance to wear. It possesses high vibration damping capacity. And these are mostly used for the preparation of manhole covers, which we are going to see on the roads. So those manhole covers, which are in circular in shape, they are made up of this grey cast iron. Frames for electric motors are made. Cylinder blocks and heads of IC engines are made. Gas or water pipes for underground purpose are made up of grey cast iron. Now we are going to see the second type, grey cast. So we are going to see what are the different applications where they can be used. Okay, see here, the manhole covers, which are made up of very strong form of steel. So it is made up of grey cast iron, where it has the ability to withstand dynamic loads. Even though a vehicle passes over this manhole cover, it can still bear that load without going inside the manhole. Okay, the manhole should be so strong that it has to bear large amount of loads. And then these are used to prepare frames for electric motors, and mostly in the IC engines they are used. Like in IC engines, the metal parts are made up of this grey cast iron, where they have to undergo coupled loading. That means, coupled loading means they have to undergo both force and heating. Okay, the IC engines are the machines which are designed in such a way that they have to undergo two different types of fields of energy at the same time. One is physical forces, like structural forces that are applied due to the movement of the piston, and heating, because IC engines mostly run on fuels like petrol or diesel. They have to experience large amount of temperature because of the combustion of these fuels. Okay, so these metals, these iron parts are made up of this grey cast iron. And then fourth application is gas or water pipes, which are laid underground for the transmission of gas or water from one place to another place. So these are also used. These are also made up of grey cast iron. Now we are going to see the different types of cast irons in the coming lectures. And that's all for this class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.